Hi, I want to welcome you to another video. I'm going to try to do these videos kind of in lecture style, um, at least this semester. This is the first semester that I'm teaching this Swift class online. And so I'm going to try to take my lecture notes that I've used for in class learning and try to use those um, for the online class. You have access to these lecture notes on Blackboard under content, I believe, and then lectures is the folder. So the numbers one looks similar to this. It's a good idea to read through these notes. What I'll do is I'll kind of highlight some things on them, talk about certain things, but a good thing to do maybe would be to print these out or to write your own notes with them if you'd like. It's really up to you how you want to do that. In Swift, and as in most programming languages or all programming languages that I know of, we've got numbers. Quite often we're wanting to do calculations. That's part of programming. And so we're going to start there. There's two basic types of numbers. There's whole numbers, what we consider integers. And those are just like numbers like 42, or here we've got 248, -10. Those are all integers. Notice that there's no decimal points. So those are integers. Floating point numbers or decimals has a decimal point. So as you see here, we got 42.0 is a float or decimal. And so is all of these numbers. 3.14, which is pi, 2.78, which is the value of e. And then you got some other values that are here. Now, whenever we're talking about numbers, quite often these are stored in variables. Whenever you think of a variable, just think of it as a place in memory that stores a value. How are variables stored in RAM, or how would like a number be stored in RAM? In Swift, we create a number by writing something like this. You can say let a equals 5, and this creates a constant named a that's equal to the value of 5. A can never change. It'll always equal the value of 5. Quite often for constants, you'll want to use something like pi or a value for gravity or something like that quite often. Something that won't change. But let's say this is RAM. This is your memory. And what happens is whenever we create a statement like this, the compiler knows that it needs to go out and allocate a place in memory at a certain memory location, and we just set that memory location equal to the value of a. So every time we reference a, it knows to go out and look at this memory location and see what that value is. We haven't talked about strings yet, but whenever I say string, just think of text, and you'll pretty much be right on. This next example here creates a string with the name of S. So S is equal to the value of hello. So in memory, somewhere in memory, the compiler will decide, okay, at this memory location, we'll put this string out here, and every time we reference the value of S, it knows to go out to this memory location and to look there for this value. That's a rough way of how memory works, so just while you kind of keep that in mind, that's good enough for most of the things that we're going to work on. There's several numeric types. We briefly talked about this before. There's integers and floats. Some programming languages don't really care, but Swift is one that does care about what you use. So if you create a variable, like we start off with a variable that we can change the value of over time, we start it with the value of var. We set the name of the variable, and we set it equal to a value. Once we set a equal to a value, let's say of 1, a can only hold integer values. It cannot hold a float. Same thing for b here. B is another variable. It's equal to 2. It can't hold another. It can hold an integer, but not a not like a float or a string or anything else. So these variables here can only hold the type that it's declared as. Now, what I would like for you to do, and actually we could have done this above, but let's say that we start now. Let's say that for some of these Swift statements, we go ahead and we create those. Let's say bar is equal to 1, and let's start off with just printing out the value of A just to see what happens. If we run this, we should get it to where it outputs a 1. Okay, that's what it does. Now I said that we could, since this is a variable, A is a variable, and let's do this. Let's do this. Let's also create a constant. Let's create a constant. Let's call it C, and let's set it equal to 0. And let's print out C and A and see what it does. It should print out 0 and then a 1. Okay, it does that, so that's good. Now, a minute ago, I said that this is a constant. That means that this value cannot change. Okay, if that's the case, then doing something like this should be not allowed. We should get an error. We should not be able to change the value of C. So let's run this and let's see what happens. Let's run this. Okay, there we go. We get an error. It says error cannot assign to value C. C is a let constant. So it's saying that we can't do this. We can't do this statement here where it says C is equal to 2. And it's going back and it's noting, hey, we need to, if you want to do this, if you want to set C equal to 2, you need to change the let to a bar. So what it's saying is that we need to change this from a constant to a variable. So let's try running this and seeing if it works. Okay, it does work. See, now C is equal to the value of 2, A is a value of 1, so it outputs 2 and 1. You see what I'm doing here? I'm playing around with the compiler a little bit to see what I can do. I'm testing it out to see if the statements and things that I'm saying are true and valid. So let's change this back to a let, and we can create a comment. In other words, we can ignore code by just putting 2 slashes in front of it, forward slashes. Notice that that changes it into like an orange color. It just means that the compiler is going to ignore everything after these symbols. So it just ignores this statement. So if we run this, it should run fine and it should output a 0 and then a 1. Yeah, because C, we didn't change the value, so C will equal a value of 0 here. A is equal to a value of 1. Now notice one of the other things that I said a minute ago is that we can change the value of A here because it's a variable. It means that it can vary over time. So let's say that we try to set A equal to 2. We click on run. Okay, it outputs C and A where C has a value of 0 and A has a value of 2. Notice here we are setting the value of A equal to 1, but down here on this line we're changing the value of A to 2. So A now has a value of 2, and so we have 0 and 2. Notice a minute ago that I made a statement that A has to be an integer. It cannot be any other value. I mean, not any other value, but any other type. So let's say that we're going to change 3 from an integer to a float, and let's say that the float is 3.14, which is pi. Now this should give us an error. Let's see if it does. Okay, it does. It says cannot assign a value of type double or float to type integer. So whenever we declare A here and set it equal to 1, what we're telling the compiler is that A is an integer. We can only use integer types. Remember that an integer is a whole number. It's a number without a decimal point. let's see, we could, since this one doesn't work, let's comment it out. And I said a minute ago that we could have negative numbers here. So let's try that. Okay, let me see what I did here and resolved. Okay, what the problem is I need to put a space there. I believe I need to put a space there. Let's try it again. Must have consistent white space on both sides. It means that we need to also add a white space on the other side. Okay, so notice there that C is equal to 0, so that's what gets printed here. A first is equal to 1, but then we change the value of A to -2, and that's what's printed here. So you see that? There we go. These are the types of things that you need to be doing as I'm going through the lecture notes. There may be places to where I kind of skip, where I don't go, where I'm not where I don't do an exhaustive amount of work in the compiler, with the compiler. You may need to do some of that yourself. I'll try to do some of that as much as I can, but there may be times to where I skip over some things. So if you read something in the notes and it doesn't make clear and you see code, copy and paste it into the compiler in the Swift WASM. Play around with it, see what happens. That's the best way you're going to learn. You'll probably learn more from there than maybe even what you'll learn from my lecture notes. So keep that in mind. For this class, you're going to get as much out of it as you put in. If you do the bare minimum and maybe watch these videos I do of the lectures and not do anything else, you'll pick up some information. But the way to really retain it is to play around with the compilers yourself, find out what works and what doesn't work. Now, what happens here is whenever we create a variable like what we have here, we also have e equal to 2.78. Whenever we have a value like this, Swift figures out what the type is, and then it assigns A to be that type from then on while the program is executing. Now, there's some times to where that's perfectly fine, but there's other times you want to take more control. And the way to do that is that, like for the value of A here, you can put a colon and then the type after it to specify what the type is. Now, for what we've done up to this point in the examples I show here, there's not really any difference between these 4 statements here and these 4 statements. In other words, the only real difference here is that we're specifying the type. But A is going to be an integer, B is going to be an integer, pi is going to be a float, and E is going to be a float. Well, you may say, well, then why do this? Well, there are times to where we want to specify what the type is. For example, let's look down here a little further. We've got a variable A, and there we've got a type called uint. Well, what does uint mean? Well, actually what it is, it's an unsigned integer. What it means is that it can only hold positive values. It doesn't hold any negative values. It just has positive values. So for example, if you know that, like for example, if you're taking scores for an exam, let's say, a percentage goes from 0 to 100. Well, there's no negative numbers in a score. The lowest you can get is a 0, the highest you can get is 100. So depending on what you're doing, it may be to your advantage to go ahead and do something like this. So that way, you're not going to get any negative numbers. And so if you want, let's go back to the compiler here. And let's say that this is a uint now. Now notice before a was an integer, and so an integer, it's signed, it means that it can have a positive or a negative value. But whenever I do this, we specified that we only want positive numbers. Notice on the next line we got a equals to -2. Since -2 is a negative number, the compiler should complain about this. Let's see what happens whenever we run this code. Okay, that's exactly what it does. It's complaining. It says error, negative integer, -2 overflows when stored into unsigned typed uint. Now, there's some fancy little words that are being said here, and think of it as compiler talk. The people that wrote the compiler is the one that created these error messages, and so sometimes they write the error messages in such a way that it makes sense to people that write compilers, not necessarily for programmers. So that's one of the things you got to do in this class is kind of learn to understand what these things mean. And really what this is saying is, hey, we cannot put a negative integer into this type, this unsigned type uint. So we have to change this to something else. Let's change this to a +2. Let's run it and see what happens. Okay, it prints out 0 and then 2, which is what we expect. Now, like I said, these can only hold integer values. I'm going to change the 2 to a 2.0. Notice that, in mathematical terms, an integer 2 and a float of 2.0, they're really roughly the same thing. They're really holding the same value of 2. But to the compiler, 2.0 is a different type. And so if we run this, we should get an error saying that it can't hold a float. Error, cannot assign value of type double to type uint. So what it's saying is, hey, we can't put this double or this float into this value of a. It has to be an integer value. And since this is a uint here, it has to be positive. So there you go. Now I'm going to leave it as an exercise for you maybe to look at some of these other values here and play around with them in the compiler. I'll leave that as an exercise for you. Now going down here a little further, you may think, well, what's the maximum value that we can put into a uint or an unsigned integer? What's the minimum value we can do? Well, from the definition of an unsigned integer, we should know that the minimum is going to be a 0. Now, depending on the compiler, this value here can be different. If you're using Xcode, like in a MacBook, the value is different. It's actually, the uint is a 64-bit number, which looks like this. But if we do it in SwiftWASM, what happens is something a little bit different. And that's okay. What this does is it allows us to know what is the constraints of our compiler. And you just need to know the compiler that you're using, what the constraints are, what's the maximum value, what's the minimum values that you can use, and then just stay within those constraints as much as possible. So here, the minimum value is 0. The maximum value is 429,496,7,295. So it's about 4.2 billion. If you have taken any other computer classes, you may know that that is roughly 2 to the 32nd power, minus 1 actually, because we start off with a value of 0. But it contains 2 to the 32 power values. Now, over here, this is actually 2 to the 64 power. But let's do this. Like what we have here on these next lines here, let's see what happens in the compiler if we just want to know the, let's say, int min and int max. Let's see what those values are as well. Okay. These are also 32-bit. This is a 32-bit compiler that we're using in the Swift WASM. So that's why these values are a little bit different than what's shown in my notes. What's shown in the notes is for Xcode, which is a 64-bit, but that's okay. It really doesn't make any difference except if you're looking at the values or you're dealing with really high numbers. For what we're doing in this class, the Swift WASM will work perfectly fine for what we need. One thing to notice is if you take with the integer, remember that it can hold positive and negative values. That means that we have about half of our values that are integers are negative, the other half are positive. So we go from this range of negative 2.1 billion something to about 2.1 billion positive numbers. If you take these two numbers and add them together, and if you ignore the little negative sign there, you will get this value here. And the reason for that is because you have only so many values that you can store in 32 bits. I may look for some other videos to post on this that explain this. It doesn't even necessarily have to be Swift videos. It's a basic computer, how computers deal with integer numbers and stuff like that. So once you learn this in one language, you can easily take this information and apply it to a different programming language. And so it's good to learn it here, or if you've already had other languages and you understand what's going on here, it's a good review. So let's continue on. Swift also has other integer types. These are int8, int16, int32, and int64, uint8, uint16, uint32, and uint64. Now the number on the end here that tells you how many bits are allocated for that memory type, or for that integer type. So for an exercise you can do is enter in each one of these to where you would change this from 8 to 16 and so on. And this will tell you what the values are. So let's go from 8. Let's change them to 8 where they're only holding 8 bits instead of like 32. I like using the 8 bits because they're smaller numbers, they're easier to see, they're easier to understand than all, those 8 or 9 numbers that you see. If you can understand it for 8 bits, it's easy then to take it to 16, 32, 64, and higher if you want. Notice here with the uint, the minimum value is 0. Remember, it's an unsigned integer. It means there's no negative value. So the lowest value is 0. The highest value is 255. The reason why the highest value is 255 is because if you take 2 to the 8th power, you get 256. And so to hold all the values, including 0, your first value of 0, your highest value is 255. So those are 256 distinct values. With the integer 8.min, the minimum value is negative 128. The maximum value is 127. 0 is considered a positive number, so from 0 to 127 is 128 values that are positive. Then you have 128 negative values, from 128 down to negative 1. I may try to find a couple of videos that kind of explains this a little bit better, so that way you can get an idea of what's going on. But play around with different values here. Put a 16 in there, but it has to be one of these values. It has to be 8, 16, 32, 64. If you try to put like int 15 in there, it's going to complain. It does not know what int 15 is. And let's just try that. It's okay to try it. The worst thing that's going to happen is you're going to get an error. So let's try it. Let's see what happens. Okay, see, it says right there, it's unresolved. It doesn't know what it means. So whenever you see unresolved identifier, really what it's saying is, I don't understand what this is. So keep that in mind. I'm sorry, I'm in a video right now. So just keep that in mind. Um, let's see.